Hello and welcome back to A Boring Revolution, your number one news source for everything in regards to The Boring Company. Hello everyone, welcome to another episode live on Periscope. Now, the plan is to post on Periscope as often as possible now and then post to YouTube. However, I'm going to take a look and see how many people are viewing the various feeds. And if it's more skewed towards YouTube, I'm going to feed it in on YouTube more often. But I guess we'll find out which is more popular. I've got an episode coming up now on the actual process of building the underground stations for the Las Vegas project. Let's just give it a couple of seconds and see if anyone's going to join us. Post any questions you like. I'm free to answer any questions you would want me to answer. Just give it a few more seconds, guys. Okay, well, let's go live into the presentation and let's have a good chat and see what's going on, guys. So bear with me on this one. At least watch the first sort of 3 or 4 minutes of the episode as we get into it, because there's quite a lot of detail in this particular presentation. Okie dokie. So, guys, construction fundamentals, Secant Piles, Las Vegas, the basics. So if you follow my previous episode, you'll know that they have started boring the Secant Piles for the project in Las Vegas. These are very critical. I'm going to explain to you why that is. The campus-wide people mover, as it's known at the convention center, is in requirement of a lot of underground stations. In fact, I could almost say it's got too many underground stations, but the nature of the project requires that it has 3 stations. Underground stations are a key element often overlooked. Everyone who's looking at the Boring Company is not paying attention to the most costly element of underground systems, which is the underground stations. If you look at the most recent extension of the New York Underground, at least 60 to 70% of the costs of building that system are because they've had to build a station underneath Grand Central Station. That is where most of the money is going. It is a money pit. It is incredibly expensive. Ideally, we'd want to keep stations or underground stations to an absolute minimum. However, on this particular job, the client has requested that we build 3 underground stations. That's what we're going to do, and I'm going to go through how we do that effectively and what they're currently using on the Las Vegas project. Estimates suggest a build cost, and this is from the actual estimate from the contract that we've been given from the Boring Company, of $8.114 million per station. And remember, there are 3 stations on this, guys. 3 stations, so it soon adds up. That is an amazing 55% of the entire project budget is just building underground stations. This is why they're so costly, and it's just an ineffective way to run a system. Hopefully in the future we're going to move more towards elevators and ramps. However, like I've said, that is a requirement for this particular project via the client. So the key statistics and facts for this particular project in terms of the contract. The Boring Company will be building 3 underground stations at a significant expense. As I've previously mentioned, $8.11 million per station. Now, there are 2 different types of stations. The end stations are 250 foot by 100 foot by about 35 foot deep. I'm not 100% sure on the depth as we speak, guys. It's around 35 to 40 foot deep. When I get confirmation, I will tell you, but it's around 35 foot. The middle station, because it's requiring a lot more passengers coming in and out of the system, is going to be 280 foot long by 100 foot wide by 35 foot deep. Concrete secant piles and tangent piles will be used, probably the latter. Now, secant piles and tangent piles are basically the same thing. There's just a minor deviation from one or the other. I'll explain that later on in the slides. There are 4 retaining walls, and these will combine to form an enclosed pit, also known as a cell. Depends what construction terminology you want to use, but they are often referred to as cells or launch pits, whatever you wish to use. There will be, I think, this is a prediction by the way, maybe 3, probably I'd say 2 levels of steel ring beams and props to create a robust structure. So we're talking about those H piles which are placed against the perimeter of the actual excavation and are there to robustly hold the excavation, the actual secant piles in place from those lateral loads. Now, why do we require steel ring beams in addition to these huge secant piles? Because some of these secant piles are 18 inches, 22 inches in diameter. They are fairly beefy structural elements. They are very robust, but in terms of these actual retaining walls, there are a lot of lateral forces, the majority of which is coming from lateral earth pressure, the actual pressure of the earth bearing against that wall. There's also the actual loads from elements that sit on top of that earth. It could be cranes, it could be concrete mixers, it could be buildings nearby, and they provide the surcharge loads. So surcharge loads and lateral earth pressure is what's going to provide large amounts of lateral forces to that retaining wall, and thus we need additional reinforcement to ensure that retaining wall is robust in the form of steel ring beams. Contract price. Now, if we look at the actual contract documentation for the Las Vegas people mover, it very quickly stipulates payment number 2. The actual boring company will get $3.72 million once it is completed the first station excavation. That is just purely the excavation. That is not fitting out that station. That is not actually getting the TBM into the pit. That is just simply digging the hole and ensuring it is structurally viable. So it's in the boring company's interest to ensure that that first excavation is constructed swiftly, robustly, and on time, because obviously they're going to get a nice wad of money for completing that. Here's the plans, which I've pulled again from the contract documentation. As you can see, we have various stations along the route. The middle station is slightly bigger than the 2 end stations by around, I think it's 40-50 foot. So we've got here a good overview of the plans and what is required. The majority of the money being spent on this project is building these 3 stations that we can see right here. Let's take a look at the contract. As you can see, the station construction is a very expensive business, and so it will be, because that is a very complex structural element going underground. A lot of pre-work to ensure that that excavation is robust enough to withstand the lateral loads that it's going to be preventing or leaning against, as it were. So you've got station excavation, $6.2 million, station concrete and masonry, $7.2 million, station metals, that'll be your ring beams and your props, and then your station finishes. Because you'll actually have a flat face against those CFA piles, which will ensure, an aesthetically pleasing finish. So you will actually end up pouring more concrete against those CFA piles, or use some kind of prefabricated solution, possibly. Here's the map of the actual stations. As you can see, they are quite big. It's covering a large part of this car park. Proposed station 1, as you can see there, it says 250 foot by 100 foot. And to the top left there, we have our pedestrian tunnel. Here's our middle station, slightly bigger at 280 foot. So 30 foot bigger than the previous station. And then here we've got our end station, 250 foot by 100 foot by 35 foot deep. Now this is a great picture because it gives us an illustration of what it's actually going to look like on site near enough. In the background here you can see our CFA piles. They look quite rough and ready, but that's how it works out basically when you excavate the pit there. You can see we've got 4 props in our video here, and if you look just below our ring beam, you see the ring beam is the concrete part there that is buffering against our props. Just below that, we have the beginning of a steel ring beam, which is being built to further reinforce this excavation. If you can see up top, we actually have a mobile crane and an excavator. They're providing significant loads to this excavation. Thus, without those props and without that second ring beam, it would actually or possibly begin to fail. It's not excavated all in one go. They typically excavate down around 10 to 12 foot and install additional ring beams, and then they work their way down to the finished floor level. So what are secant piles? If I was going to determine what they are in a quick sentence, it would be a long circular cylinder of concrete bored using a CFA rig. CFA rig's continuous flight auger, which is basically the drill that makes the hole in the ground and injects slurry as it's removing soil from that excavation. Each pile interlocks with the preceding pile, forming a retaining wall. Now, there are different types or systems for using secant piles, which I'm going to go into later on. They don't necessarily need to interlock, but they do need to be very close together, i.e. the gap needs to be less than 30 millimeters if possible, because otherwise you will have some issues. You need it to act as one structural element rather than 150 individual elements. That is where you get your lateral resistance from once you add your ring beams. Multiple CFA rigs allow for quick construction. You don't necessarily, you could have 6 teams if you really needed it to, all operating individual CFA rigs. As long as you've got your excavation set out and ready to go, you can have as many rigs as you want. But obviously more rigs equals more expense. But if you're desperately in need of saving time, you can use as many rigs as you want, which is a good advantage to the system. The piles require reinforcing with ring beams and props. The piles themselves are reinforced with rebar, but that is not enough to withstand all the lateral forces upon this actual excavation, so you will need ring beams and props. There are ways that you can remove the ring beams and props at a later date, but often it proves more cost effective to leave most of the ring beams in place and then simply hide them once you have finished construction of that station. Now, let me break down the process. I've mentioned tangent piles and secant piles. As you can see with secant piles, they interlocked or interject with each other. That is really, really good if you are working on a site which has a high water table or in an area which experiences large amounts of rain. Because as the soil becomes more saturated with water, the actual loads or lateral loads imposed on that retaining wall increase greatly, and also the secant piles prevent water from trickling through the piles, going into your excavation and creating this quagmire, which I can tell you from first-hand experience is not an easy place to work. There are various means you can use primary and secondary piles. So your primary pile isn't reinforced, as you can see from our central picture on the left. It isn't reinforced, it uses a weaker form of concrete, and then your secondary piles are reinforced and they are cut into the primary piles and they provide this cohesive retaining wall. If, however, you operate in an area which doesn't have much rainfall and has a very low water table rather than a high water table, you can use tangent piles. Now, the tangent piles don't necessarily need to touch, but they need to be fairly close together. The issue with tangent piles as well is you need to install your ring beam at an early opportunity because they're not locked in together, but it's not necessarily that difficult to do. I'm of the opinion that potentially In fact, I'd say there's a good probability that in Las Vegas, tangent piles might actually be more useful for the station excavations. So there's a very high probability they might use tangent piles for that, because if they're going to finish the stations with a concrete wall anyway, it doesn't necessarily need the piles to be interjecting. But as you can see, there's different ways of doing it. The easiest way to do it is the tangent piles, because they don't need to interlock. But if you really need to have a watertight pit or cell, then you can use the secant piles, and it just requires a minor modification to the auger, slightly different tooling on there, and you can have a perfectly or almost perfectly watertight excavation. I found these illustrations on the internet. They are really excellent to show you the process with which the actual retaining walls are constructed. The most important thing that they've missed off, really, which is unfortunate, is that the first thing you do when you come on site after you have cleared the topsoil is you install these guide walls. But before you get to the guide walls, you need to create an excavation around the perimeter of your pit. That excavation is usually around 2 to 2.5 foot wide, around 6 foot deep. Once that has been constructed and reinforced, you can then sort of shuttered, you can then install your guide walls. And your guide walls are there most importantly to ensure that the casings are installed at the exact positions they are required and at 90 degrees, so perfectly vertical. So as you can see, we've done our excavation here for our secant piles or tangent piles. We then shutter out the excavation, install our guide walls. At that point we can get our heavy machinery on site, so we've got our vibro hammer. We can then install our casings. The vibro hammer vibrates the casings very quickly, so the casing is probably around 6 to 8 millimeters steel, tubular steel. That's vibrating very fast, and that drives the casing down into the ground. Once that is there in the ground, each casing, so the casing actually comes in various sections depending on how deep you're going. So I'd imagine for the Boring Company it would come in 3 parts. So you'd initially have an 8-foot piece or primary piece that would start the casing, and then you would have 2 12 to 14 foot pieces that you would then slot on top, locking together, drive that in, then bring in another piece of casing, slot that on top, lock it in, then drive that down. At that point, the casing is gone. The casing is gone the majority of the way. Sorry about that, guys. The majority of the way down into the pile. So you've gone pretty much all the way down. You can then bring in your auger. Now the actual casing doesn't need to go down all the way to the bottom of the pit. What you can do is, if you're using a CFA or continuous flight auger, is as you are drilling down and removing that soil and that rock, you can inject bentonite slurry. That bentonite slurry is going to fill up the bottom of that excavation, and it's going to prevent the walls of the excavation from falling in on itself, which then allows you to pump concrete in. And as the concrete is pumped in, the bentonite slurry rises to the top, and then you can simply just withdraw it from the excavation. So what you do before this as well, which we've actually not mentioned, is you install a rebar cage. Now, in this particular method, they're not using rebar cage because they're using a primary pile that is just purely concrete. But I imagine with the depth of the Boring Company's pit, they will require reinforcement in every single pile. So you'll have a circular or cylindrical rebar cage, which will be dropped into the concrete. So you'd have the wet concrete, you would drop it in, push it down, and we're talking a really long length. You'd use quite a considerable crane to drop in this rebar cage. It'll typically be around 36 to 40 foot long. You drop that in there, and then it would push it all the way down to the bottom of that borehole, which is full of concrete, which is curing. Now, once you've done your primary piles, you're going to install your secondary piles in between. You can either use your auger to cut into the piles that are either side, or you can leave yourself just enough gap to install some more casings. Then you can install your concrete into those casings, then your rebar, and then you're all done. And that would actually be a more useful system for Las Vegas, because I imagine that the water table is very low and actually won't come into play during the excavation. Once that is all done and all your piles have fully cured, so you're going to have to wait close to 2 weeks for those piles to cure, you can begin excavating, you can begin installing your ring beams, and as you install the ring beams, you can then dig further down, install more ring beams, and then you're going to pour your finished slab for the bottom of your pit. Now, we kept things fairly simple in this explanation, but there is another way of doing it without the ring beams. You can use tie bars. Tie bars are a very, very specialized area. These are post-tensioned steel bars that are installed to anchor the actual walls of the excavation into the existing bedrock. If you have good bedrock, you have solid ground, that works really rather well. You will still need, as you can see on the left hand corner of the screen, these concrete kneels with steel props. Actual tie bars actually make more sense, but they do tend to cost more and require more expertise. But it's worth throwing it out there to say this is one method that the boring company could consider using on a future project. But I expect they'll use ring beams and large numbers of props. This excavation, just as an example, is close to 70 foot deep and well over 120 foot wide. It is a big boy, and it is probably as big as you will see. So, what opportunities are there for the boring company in terms of how we can further improve the construction process? Because if, as I've explained at the start of this video, a very, very large proportion of your costs of construction are building these launch pits or these underground stations, does it not make more sense to invest in the process and find ways to do it more quickly, to do it to a higher quality standard, to do it more cost effectively? I think there are a few opportunities here. However, it will require them to make an acquisition, so to acquire an existing groundworks subcontractor and then adapt the machinery that they own, or maybe acquire new machinery to fit the purpose of the boring company. So what the boring company could do is take a feather from Tesla's cap, as it were, and introduce more vertical integration into the company via acquiring a subcontractor with a speciality in this field. They could then maybe redesign the machines to fit their purpose, to make them more cost effective. So if they have their own team that are doing their own jobs, they work directly for the boring company rather than being a subcontractor, then becomes much easier to introduce continuous improvement methodology once that process is in-house. So you train and retrain your own people and introduce new methods to build the Secant Piles. The process can be further streamlined and refined for future projects to enable time savings, spec improvements, and cost savings. If you could make the piles thinner and you could use less reinforcement, that would introduce quite a big cost saving to the overall process. Also, if you could automate the process of installing piles, not fully automate it, but automate 90% of the process, that again would further improve the cost effectiveness of this system. There are some minor concerns from what I've seen about what the Boeing company is doing at present at Las Vegas with the current subcontractor. The CFA rigs they are using are diesel powered, very powerful rigs. They're obviously going to produce quite a lot of pollution, both CO2 and particulate matter 2.5. It's possible in the future, maybe in the next 3 to 5 years, they could electrify all these CFA rigs using technology from Tesla. Concrete as well. This process involves many hundreds of tons of concrete, if not thousands of tons. It's going to be very CO2 intensive. So they need to invest in technologies for sequestering CO2 into concrete, but also capturing CO2 during the production of the cement for this concrete. Excellent. So we have reached the end of my presentation. I hope you've stayed with me. If you stayed with me this long, amazing, guys. I appreciate it was quite a long presentation today, but there's a lot of detail that I need to cover. Obviously, I am from the construction industry. I understand these processes very well. I want you to understand it as well. I want you to understand how these things go together, because when I'm bringing out lots and lots of pictures from Las Vegas and I'm talking about CFA piles and secant piles, and CFAs and augers and this sort and ring beams, I want you to be able to look at this video and say, I understand exactly what Will's talking about because he explained it to me, and I understand that the Boeing company is making great progress here and we should be very proud of them. So please like and subscribe to the YouTube channel. Please like and subscribe on Periscope, on Twitter as well, guys, so you get live updates of when I go on with my videos. I'm live streaming. It's better for me if you're watching it live and then can ask me questions as I'm going along. Also, definitely join me on Discord. There's a lot of good conversations happening on our Discord channel, and I'd really welcome you to come and join us there. There's also Twitter and Instagram. Also, my Patreons, thank you so much for your regular donations. This really helps the channel. Obviously helps pay for my Ecamm Live subscription, which is this software that I use to broadcast this, which is phenomenal. They update it every 3 to 4 weeks, which is brilliant. It's so smooth. It's so easy to use. I really love using Ecamm Live. So thank you to my Patreons, Ashley, Mike, David, Christopher, and Jim as well, my new Patreon. Thank you so much, everyone. We really appreciate you coming on with this process. There's so many good things to talk about. We have someone live, which is excellent. So if I go to Brian Robert Smith. Yes, Brian Robert Smith. Excellent question. So, how can the Boeing company produce a low carbon dioxide or CO2 concrete? It's difficult, but it involves the whole process from extracting the limestone to turning that into cement. The process of making cement is very CO2 intensive, because when you're heating up that limestone and that clay to make the cement, that produces a lot of CO2. Firstly, from the natural gas that you're using to heat the cement, the limestone, but also the actual chemical process produces a lot of CO2. Now, if in that manufacturing facility you had a way of extracting the CO2 and pulling it out as you are making the cement, that would make an absolutely monumental difference to the amount of CO2 going into the atmosphere. But even better than that, you could then sequester that CO2 that you've captured and stored in pressurized containers, inject that straight into the concrete at the concrete batching plant, then send that to the site, and they could put that into the piles. They could put that into the precast concrete segments. So you could end up with a concrete that produces 90% less CO2 than your traditional concrete, which is very clean. Concrete is a monumental, yes, carbon cure. Yes, excellent point, Cormac. Thank you for joining us. There's there's another company as well that I was recently watching on CNBC, and they've produced a new blend of cement that can be used, and it is something like 60% less CO2 than the traditional cement, than the traditional Portland cement. Unfortunately, I've forgotten the name of this company. They are a startup company. The trouble is, to produce concrete using the cement, it has to be in a factory facility, so that wouldn't be useful for our CFA piles. However, I've been recently following them on Twitter, and they have come up with a new blend that can be used in wet concrete mixes. So again, there's a lot of innovation in this sector in concrete. You know, we've been pouring concrete for 170, 180 years, and there's still lots and lots of innovation to be pulled out of that scientific process. So, yeah, so much opportunity in concrete. A lot of people are shitting on concrete, saying it's a bad material to use because it's high CO2 intensive. But you've got to remember, concrete is going to be in the ground there for 150 years, no problem. So if you build it and then you get 150 years out of it, if you look at how much CO2 was produced during the curing process, then really, you know, there's not really that much CO2 because it lasted 150 years. Okay, guys. I'm going to shoot off unless you have any questions for me, guys. Please get on the Twitter page and subscribe to my channel. If you hit the bell button at the top and you click notify for live videos, every time I go live on the Periscope, you'll get a notification. If you miss that, hit the bell icon on YouTube, because I'm always going to post this video on YouTube as soon as I've finished with the broadcast. Okay, guys, thank you for joining me. Appreciate all your support, guys. Any questions before I go? Anything whatsoever? You've got, I'll give you 30 seconds, guys. Any questions whatsoever? And then I'm going to call an end to this stream. Thank you for the like, whoever that was. Appreciate it. If you've not done so, definitely get on the Twitter, guys. Subscribe to the channel, because I post pretty much daily onto my Twitter feed all the latest news. And hopefully we should have some pictures of the Las Vegas project in the construction phase very soon, hopefully over the next couple days. Okay, so Mayor for Dublin, my good friend Cormac. Any news on China? I'm going to be very honest with you. I've not heard a peep. Very, very disappointing. I was hoping that we'd be able to hear some big news about a company being formed in China for the purpose of building the TBMs, or maybe just recruiting engineers, but nothing. Right, guys, I think that's it for me. Remember, guys, don't be boring. Hopefully see you around again. Okay, take care and goodbye.